Think about what would happen if you entered a black hole. It seems like this is an ordinary scientific question, but no one can exactly say what happens inside a black hole. Perhaps black holes are one of the greatest mysteries of the universe. When a star dies, it can turn into a black hole, but whatever enters a black hole never comes out. Now, if that thing is a human, what happens to the human body? How do black holes even swallow time? And what exactly is the singularity of a black hole? None of these questions have definitive answers. But today we want to delve into this topic together and examine some theories that might solve these mysteries to some extent. If you want to get to know more details about black holes and their mysterious world, watch this video until the end. By the way, thank you for liking the video right now and turning on the channel's notification button, because this is the only way to support the efforts of the executive and research team of this channel. But black holes are one of the strangest and most mysterious phenomena in the universe. Even though they are frequently mentioned in movies and science fiction books these days, their reality is more complex and frightening than anything we can imagine. To understand how black holes operate, we first need to understand what causes a star to die. In general, stars are incredibly large collections of hydrogen atoms that undergo nuclear fusion in their cores. In fact, nuclear fusion is a physical process in which atomic nuclei combine to form heavier and larger nuclei. This means they convert hydrogen atoms into helium. When this happens, a tremendous amount of energy is released in the form of light and heat, which is what makes the star shine and produce heat. In other words, this tremendous energy is in the form of radiation, but more importantly, it resists gravity. And as long as fusion continues in the core, a star remains stable. However, when stars reach the end of their life, the core of a star gradually transforms into heavier elements like iron. Unlike all the elements that were previously formed, the fusion that produces iron does not generate any energy. In this way, iron accumulates in the center of the star until it reaches a critical amount, and the balance between radiation and gravity suddenly collapses, resulting in the core collapsing and the star exploding in less than a second. In fact, this collapse causes the star to have a massive explosion known as a supernova. This is indeed where black holes can be born. When a very large star explodes, the entire mass of the core turns into a black hole. A black hole itself is nothing but a dark region from which nothing, not even light, can escape. This region is known as the event horizon, and the hole within the black hole is called the singularity. Well, let's explore this topic a bit more. In fact, the event horizon is the boundary or limit around a black hole, beyond which nothing can escape. Not even light can come out from inside the region. This is why black holes appear black. This means if something, like a star or a spacecraft, crosses this boundary, there is no way to return, even with the speed of light, because even light cannot escape once it has fallen in. But from the outside, it seems that this object no longer moves and slows down, because time also passes strangely slowly in this region. Thus, the event horizon can be likened to a point of no return, where all paths lead to the singularity, a point where space and time completely disintegrate. Now let's talk more about singularity. The singularity of a black hole refers to the point at the center of the black hole where all the mass of the black hole is infinitely compressed and concentrated. In fact, the singularity is a point where everything reaches a zero volume and infinite density, meaning even our scientific understanding of space and time no longer applies at this point. Most importantly, we cannot directly observe or precisely understand the singularity, because all theories and laws of physics as we know them break down at this point. In fact, the singularity remains a mystery that even the greatest physicists have not been able to fully explain. The singularity is where space and time are intensely warped. This point is exactly where all the mass of the black hole is concentrated. Singularity means infinite density, meaning it is the most compact point. Cosmos. However, the notion that black holes suck in everything like a vacuum cleaner is not quite accurate. Imagine replacing the sun with a black hole of the same mass. In this case, Earth would never leave its orbit, but we would certainly die from the cold, because no light or heat would reach us from the sun anymore. Now, what happens if someone enters a black hole? When you enter the event horizon of a black hole, time starts to slow down, meaning that from the perspective of others, you progress slower and slower until you eventually disappear. However, from your own perspective, everything around you moves faster. In a way, you enter the future. But entering a black hole is accompanied by death. But what is this death like? Of course, this is a relative question that depends on the size of the black hole. If the black hole you enter is small, you might even be killed before reaching the event horizon, because the gravity becomes so intense that your body is split in two and stretched. But if the black hole is very large, you can survive for a longer period. However, ultimately, death will be inevitable. Now, perhaps this question arises for some. Is it possible to escape from black holes? The first and shortest answer scientists give to this question is that no, it's not possible. There are some theories that examine other conditions. Some physicists believe that we might be able to pass through a black hole and reach a parallel universe. But this is just a hypothesis because there is no evidence to show that it is real. But the interesting point about black holes is that they eventually disappear. This happens through a process called Hawking radiation. This process is very slow and can take millions or even billions of years, but eventually, black holes evaporate. According to the theory of the famous physicist Stephen Hawking, black holes gradually lose energy and eventually evaporate, contrary to what was previously thought. In fact, when a black hole loses energy over time, the mass of the black hole decreases, which allows black holes to eventually evaporate. Of course, the evaporation of black holes means that when a black hole becomes very small, it releases a lot of energy and disappears with a massive explosion. This explosion is so intense that it has energy comparable to billions of nuclear bombs. So in general, black holes first evaporate. That is, they slowly lose their mass and energy, and then when they approach the final stage, they have a massive and energetic explosion that accompanies the death of the black hole. This process is very long and slow, and we won't exist at that time, because by then the universe will likely have become uninhabitable. However, ultimately, all black holes must follow this path. Let's remember that the universe is still full of mysteries that we haven't fully understood, and everything that happens in life, even black holes, are all part of a bigger plan that we may never be able to fully comprehend.